Hi everyone. Today we're going to look at adding and subtracting rational expressions. Now when we add and subtract rational expressions, they could have the same denominators or they could have different denominators. They look a lot like fractions. So before we actually get into adding and subtracting rational expressions, I thought it'd be best to add and subtract fractions as a good review. So when we go through our steps, first thing we want to look at is our denominators and make sure that they're the same. Now looking at this, we have 2/9 plus 4/9. They're the exact same denominator. Next up, we want to look at our numerators. And our two fractions are combined by addition, so we're going to go ahead and add 2 plus 4. And that will be over our common denominator of 9. Now 2 plus 4 equals 6, so I have 6/9. And then we finally want to see if we can simplify, if there's anything in common to both the numerator and denominator. And in this case, 6 and 9 are both divisible by 3. 3 goes into 6 2 times, and 3 goes into 9 3 times. So we end up with the fraction 2 over 3. So 2/3 would be our answer in simplest form. Now our steps for rational expressions, adding and subtracting them, are very similar to what we just did with those fractions. We first want to look for the least common denominator. Now on the problems we're going to do today, the denominators are already the same, so we don't have to worry about finding a least common denominator, something in common for both. So we really don't have to worry about step 2 either. So let's look at step 3. Add or subtract the numerators. Just like we added together the numerators on the previous problem, we're going to do that with the numerators of our rational expressions. Now, if we're subtracting, it's like we're distributing a negative through that second expression, whatever comes after the minus sign. We have to distribute that minus sign to every term inside or after that minus sign. Then we're going to simplify the numerator by combining like terms. So if there's something that has an x, you want to combine all the x's together, all the y's together, etc. Then we want to check to see if the numerator will factor in or the result will simplify further. Just like on the previous problem, the numerator and denominator had 3 in common, so I could divide both the numerator and denominator by 3 to simplify it. So now let's try this with a few examples. Now, like I said, all of our examples today will have like denominators. We don't have to worry about finding that least common denominator. And if we look here, both of our denominators are 6x cubed y. So I can go ahead and write one big fraction where 6x cubed y is my denominator. So I first have my x minus 3y. I have my minus sign. And I'm going to subtract the quantity x plus 3y. Now that minus sign is going to be distributed to both terms here. So now my numerator would be x minus 3y. So this is still the same as what we had there. Then we have minus x minus 3y. And that's all over 6x cubed y. So now we want to simplify that numerator and combine like terms. Well, x minus x is 0, so we don't have to write the x term down anymore. Negative 3y minus 3y is minus 6y. So my new numerator will be minus 6y, or simplified numerator. My denominator is still 6x cubed y. We then want to look at simplifying. Well, both the numerator and denominator have a 6, so those can be factored out. And both have a y, so those can be factored out. The only thing left in the numerator is a negative 1. And then my denominator would be x cubed. So this would be my simplified answer. Negative 1 over x cubed. Our next one has a little bit more of a complicated denominator. And you might at first think about factoring it, but let's wait until the very end to see if we should factor. Okay, so this time we're adding. And looking at this, they have the exact same denominator. So I'm going to write this as one giant fraction over x squared plus 3x plus 2. So I have my 5 plus 6x plus 1. Now we want to combine any like terms in the numerator. And if we do that, we can combine the 5 and the 1. 5 plus 1 is 6. So we have 6x plus 6 over x squared plus 3x plus 2. Now at this point it doesn't look like anything could be factored out or simplified. Now I want to look at factoring it to see if that is possible. Now looking at the numerator, they have a 6 in common. So I could factor out a 6. And so I'd have 6 times the quantity x plus 1. My denominator x squared plus 3x plus 2, that's going to be the same as x plus 2 times the quantity x plus 1. Now looking at our numerator and denominator, they do have an x plus 1 in common. They have that common factor. So that could be factored out. And now I'm left with 6 over x plus 2. So 6 over x plus 2 would be our final answer. And one last example for the day. Another subtraction problem. And our denominator is a little bit complicated looking. Okay. I'm going to leave it alone for right now. 2x squared plus 13x plus 20. Here we have 5x plus 7 minus, I'm going to extend that bar a little bit, the quantity 3x plus 2. So I'm going to have to distribute that minus sign through my parentheses. When I do that, I now have 5x plus 7 minus 3x minus 2. And all of that is over 2x squared plus 13x plus 20. Okay, so now we want to combine those like terms. Okay, so 5x minus 3x is 2x. 7 minus 2 is 5. And we still have our 2x squared plus 13x plus 20 in the denominator. Now at this point it doesn't look like anything can be simplified, but we want to take a moment to go ahead and factor that denominator. So if you want to pause the video and try to factor it, you can. I'm going to give you a moment. Okay, if you factored it correctly, it should be 2x plus 5 times the quantity x plus 4. Now the 2x plus 5 are common to both the numerator and denominator, so those can factor out. Now that doesn't mean that there's nothing left in the numerator. We still need a 1 there as a placeholder. And then x plus 4 will go in our denominator. So this will be our final answer. Now since we are dealing with fractions, we do have to think about restrictions for our denominator. There's certain values that it can't equal. So if you look back, let's go back to the first one we did here. If we look back at our original denominator, this one here, we have to think of what values would make that equal to 0. So x can't equal 0 because that would make the denominator 0. And y cannot equal 0 because that would make the denominator 0. On that next problem, it's best to look at this factored form here. The x plus 2 times the quantity x plus 1. And x can't equal -2 or -1. Because if we plugged in -2 or -1, that would make our denominator equal to 0. And finally, on this problem, We looked at this factored form. Then what values would make this equal to 0? It could be -5/2 or -4. Either of those numbers would make the denominator equal to 0. So that concludes our notes for the day. If you have any questions, feel free to email me and let me know if I can be of any help. I'll talk to you tomorrow. Bye.